am the Director of Spatial Technology at the Center for Spatial Studies at the University of Redlands. So we help with both research for students and faculty, as well as we teach a lot of the classes in spatial studies and geographic information systems.
Awesome. Okay, so first question, can you describe the process of taking images from the drone and converting them into a 3D map? What kind of software is used to do that?
Okay, so the drone itself is taking, it has a regular camera on it. There's nothing special about that camera that helps us create 3D surfaces. It's the same kind of camera that you would have in your phone. It's just a digital camera. A single photo from a single location, even if we zoom, if we take it really high up in the air and take a picture of a large area, that photo itself is not measurable. So you can't measure in any way and get and convert that to real measurements from a single photo. The only truly accurate location is the very center of that photo. As you get to the edges, you get more distortion. And so we need to be to make a 3D surface and something that's actually measurable in 2D or 3D space. We need to look at objects at two or three different angles. So it's the same idea as how our eyes work, right? So our eyes work using something called stereoscopy. So we have two eyes. If we close one eye, we lose any kind of depth perception. We lose our depth perception, so we can't even tell how far something is away, how big that is. And it isn't until we look at that same object with both eyes, looking at the same object at two different angles, that we start to understand that and get that the distance and the size back. So the process of taking those photos and turning them into measurable images is a process called photogrammetry, which is as old as photography is. Ever since we took a picture, we've been wondering how we can use that for science purposes and use that for measurements. And with drones, it's just a little bit different approach. But so every photo that we take in about a 15 to 20 minute flight, we'll probably take hundreds of photos. Each one of those photos has something about 75 to 80% overlap in each one of those photos. So there's a lot of commonality between each photo. But that means that we're looking at all the objects in those photos at different angles. And by comparing those different objects at those different angles, the software that we use called Pix4D is able to triangulate those different objects and in 3D and 3D space, and then make a 2D surface, a 2D image result measurable, and that's known as an orthophoto. It's one that's been corrected for geometric distortions.
Did you custom build the software you use, or is it publicly available?
It's publicly available. It's a commercial software. It's called Pix4D. It's one where you use Pix4D Mapper. That's what it's called. And there are probably three to five other big names in that space, but Pix4D is kind of the biggest one right now. And there are a couple of open source software packages. And again, we use those. We use this open source packages way back, actually before Pix4D was around, to do the same kind of processing with kite aerial photography. Before we had drones, we basically put a camera on a kite and pull it around and take a bunch of pictures on a time interval. And but we were able to do the exact same thing using those images.
What kinds of projects have you done, and what are your maps that you've been used for?
Well, the coolest one is our work in rainforest in Panama, in the Mamani Valley watershed. And so we go down there every year, except for 2020, we couldn't travel, but we go down there every year with a bunch of students, and really doing a lot of things down there. But we teach them a lot of GIS, and that includes doing a bunch of drone work. And we fly drones over the rainforest to get a sense of how it changes year to year. Try to get an understanding of the health of the forest, the health of the water network there, and they'll regularly see like people doing kind of slash and burn type things. So, trying to get a sense of how that changes year to year is pretty cool. And we actually send those photos down to the communities that live down there so that they can better manage their land. So that's kind of a fun one that we do. But we fly. We do regular surveys of the University of Redlands campus. We do a lot of the other kind of open spaces in and around Redlands. We do regular surveys for different student and faculty research projects. So, I mean, anybody can get fairly decent, aerial photography now just by going to Google, right? And that's, in many cases, that's fine for somebody's project. Drone mapping, the big difference would be, one is the quality, is that you can zoom down in and see, cracks in the sidewalk. You can see sticks on the ground and rocks, and, depending on how the quality that you need. But the other issue is the time scale. I can go out and fly something and get a very accurate depiction of what what an area looks like today versus what's in Google, which might be anywhere from a year to 5 years, depending on where you live. That might be 5 years old. Coming back to Panama, a problem that you have in the tropics is that all that is satellite based, and in the tropics, good portion of the time you're covered with clouds. And so even the best images that you get in the tropics are just covered with clouds. It's really hard to find a good image that isn't. So it becomes even more important, down there. So you're below the clouds instead of trying to get at them above the clouds, which is an important issue down there. So, but yeah, any number of projects for environmental research, for biological research, just for land management in general, facilities management. Those kinds of projects, need timely, high quality imagery for their projects.
Mm-hmm. Has Has your program been implemented in other schools, or are you still the only ones doing it?
No, lots of schools are doing drone. It made the GIS industry cool again, for one. Mapping. It makes it. It's a kind of fun new topic in the field, and it gets a lot of students interested in GIS and mapping in general, because it's fun to go out there and do field work, and it's. But a lot of schools are doing GIS. Drone programs now, and we actually don't have a program that teaches you. We do a few classes and little workshops and stuff, but we don't have any classes that are specifically like how to fly a drone with a fleet of drones, and everybody goes out and practices going through hoops and stuff like that. There are schools that have those kinds of programs. It's not something that we've done yet, but are considering it. But we do a lot of workshops and stuff about how to fly them, but also then how to do all the processing and everything. Yeah. But I've even seen at high schools that people are starting little drone programs, little drone clubs and stuff like that. Because we have for our workshops, we have 10 or 15 little mini drones. They're about this big. They fly really well, and you just fly them with your phone, so everybody can take turns and learn kind of how they work, and you can even take some decent photos out of them and do photogrammetry at some scale with them. So that's kind of fun.
Here's a question, because your company uses the Phantom 4 drones, right?
We also use the Mavics, which are also made by DJI. Yeah, but that's kind of what we also fly. We have a few fixed wings drones, which are hard to fly. They're like little miniature planes, and those are a lot more complicated to fly. They take a lot more thought. You have to, essentially have a runway, or some big grassy area or something that you could land them on. The fixed wings that we have don't have any kind of landing gear, so you basically just they kind of just land on the grass or something. And we have crashed those multiple times in spectacular ways. But the idea behind those is that, at least in the construction of them, is they're basically styrofoam. And so you can replace the pieces for like the wings are like $10, right? You can replace them pretty quickly. The most expensive piece in it is the little computer and the camera that's in them. So
what is the cheapest drone that you guys use?
Well, for mapping,
like you mentioned the mini drones,
those are about $100.
Okay.
About $100.
That's cool.
And they're very stable. You can get the difference really is in the drones that you buy. You can go and pick something off the shelf at Rite Aid or something. I think at this point, a lot of those though don't have an accelerometer in them, and they don't have any kind of GPS or anything. So you're controlling it and trying to keep it level, and it's tricky. With anything a little bit more expensive, it's keeping itself stable, and if you let go of the controls, it more or less just, if it has a GPS in it, it'll just stick there. They're really easy to fly. And the $100 ones that we have, I can't remember the model right now, but they have an accelerometer in them, and so and you can fly them indoors pretty easily. They don't have GPS, so they're not just going to stick there if you put it down, but it might kind of drift a little bit, but they're pretty good. On a windy day, it would be tough. but but then we use Phantom, DJI Phantom, and we've started using those at a Phantom 3, and anymore I think you can get those for a few $100, and they're great. Even the older ones, the Phantom 3s that you can get pretty inexpensively, work great for this kind of stuff. Most of the advances have come in object detection, and some kind of in the software, but not necessarily in the hardware. There's been a few things, but so even the older models work great. The ones we use are anywhere from $1,500 to $2,500, but you can use a much cheaper, like entry level drone to do this kind of stuff.